morning children. Let me continue rational number. In the rational number, the last two main I have explained orally in the previous class. Let me have written already in the board because it is very easy, so I have already written in the board. So write the rational number that doesn't have a reciprocal. So number which doesn't have a reciprocal is 0, isn't it? 0 doesn't have any reciprocal. So you can write the answer is 0. The rational number that are equal to its reciprocal. So if I write 1, what is the reciprocal of 1? Again 1 by 1, that is 1. If I consider minus 1, what is the reciprocal of minus 1 by 1 is 1 by minus 1, which is again minus 1. So the answer is 1 and minus 1 are the numbers which are equal to its reciprocals. Okay. Then the rational number that is equal to its negative. So negative means you will have 0 only because 0 has neither positive nor negative. But other numbers definitely it will change when you put negative. So you can write this is also equal to 0. Similarly, let me write the fill in the blanks. 0 as, just now you told, there is no reciprocal. 0 as no reciprocal, first one. Then the numbers dash and dash are their own reciprocals, the second one, isn't it? 1 and minus 1, their own reciprocal. Even if you find the reciprocal of it, you get the same one. The reciprocal of minus 5 is, so minus 5 by 1, so that it becomes a rational number. When you write the reciprocal of it, you will write 1 by minus 5. So you can write 1 by minus 5 or minus 1 by 5. Both are one and the same. You can write this also minus 1 by 5. Anyway, it is same. Then, what is the reciprocal of 1 by x, where x is not equal to 0? So, what is the reciprocal? You write the inverse, that is x by 1, that is x. So, the answer is x. The product of two rational number. So, when you multiply any two rational number, the product is a rational number itself. So, when you multiply, that is the closure property, isn't it? When you multiply any two rational number, the result is also a rational number. See, 1 by 2 into 3 by 4. Multiply 1, 3 is a 3, 2 4s are 8. So, the product of two rational number is a rational number. The reciprocal of a positive rational number. So, if I have the reciprocal of this with a positive sign, so what is the result we have? Positive sign only, isn't it? So, the reciprocal of a positive rational number is positive. Here he has not given any number, so you can write the reciprocal of a positive rational number is positive. Of rational numbers on the number line. You know, when I begin the natural numbers, I will begin with 1, 2, 3, 4, 5. It goes on. Okay. So, for the natural number, if the line extends indefinitely on the right side of 1. So, when I write a natural number on the number line, so the number line begins with 1 and the other numbers are continued towards the right side indefinitely, because natural numbers are infinite set of numbers. So you can go on writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 like that. Okay. So it can be extended indefinitely only to the right side of 1. Then whole numbers. So if you consider whole numbers, whole number again begins with, yes, 0. So 0, 1, 2, 3, 4. Again, you can write the numbers indefinitely to the right of 0. For this natural number, it is right of 1. Whereas for the whole numbers, it is right of 0. What about integers? So, in between 0, to the right of 0, it will carry on with 1, 2, 3, 4. And to the left of 0, it will have negative integers, -1, -2, -3, -4. So, it moves indefinitely both the side. Towards right, they are positive. Towards left, they are negative. So now, after rational integers, there comes a rational number. So rational numbers are in the form of p by q. So you have to write in the fraction form. So let me have 0 in between. So if I divide in between 0 and 1, so you get 2 equal parts. This is one part and this is second part, isn't it? So 2 equal parts. So this portion will become 1 by 2. There are 2 parts. So 1 by 2. So 1 by 2 is in the form of p by q, isn't it? So what this will become? Yes, 2 by 2, which is equal to 1. 2 by 2, which is equal to 1. Similarly, you divide this side also, 2 equal parts. Okay? So here you will get -1 by 2. Because towards the left of 0, all are negative. Then this is -2 by 2, which is equal to -1. So if you divide 2 parts equally, you can write 1 by 2. Okay. Similarly, if I write, see, let me consider 0. This is representation of -half and +half. If I want to give you, so why don't you show me 1 by 3 on the number line, 3 by 3 on the number line, 4 by 3 on the number line, 5 by 3 on the number line. If I ask you to represent these rational numbers on the number line, how will you represent? First you see it is divided into 3 equal parts. See the denominator. It is divided into 3 equal parts. So between 0 and 1, you divided into 3 equal parts. Okay? So the first part will be 1 by 3. Second part will be 2 by 3. And the third part will be 3 by 3, which is equal to 1. What about the next part? Yeah, 4 by 3, 5 by 3, and the next part is 6 by 3. 6 by 3 is nothing but 2. 3 2s are 6. So now you can write 1 by 3, which we have asked. Then 1 is nothing but 3 by 3. Then 4 by by 8, 5 by 8, 7 by 8, 12 by 8. So when you want to represent, all are positive. So you must see the denominator. Denominator contains how many parts? 8 parts. So divide 8 parts equally. 1, 2, 3, 4, 5, 6, 7, 8. So you see, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the first one is 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, 8 by 8 is 1. Okay. So 2 by 8 is already given. 5 by 8 is over. I want 7 by 8. Yes, over. After that 12 by 8. So after 8 by 8, you will have, yes, 9 by 8, 10 by 8, 11 by 8, 12 by 8. It goes on. So you can see this is on the number line. So how to represent the rational numbers on the number line, you know now, isn't it? Okay? Yes. Similarly, show the rational number four by 9 and minus 7 by 4 on the number line. Okay. So now, in the first case, the number line to be on the positive side, isn't it? So 0. See the denominator. So it should be divided equally into 9 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9 by 9 is 1. So you can write 1 by 9, 2 by 9, 3 by 9, 4 by 9, 5 by 9, 6 by 9, 7 by 9, 8 by 9, 9 by 9 is 1. So I want 4 by 9. Okay. Similarly, I have to represent minus 7 by 4. So it is towards negative. So 0, 1. So see the denominator. It is divided into 4 equal parts. So let me have 4 equal parts. 1, 2, 3, 4. Minus 1. So let me write minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4, then yes, minus 5 by 4, minus 6 by 4, minus 7 by 4. Okay. I have represent minus 7 by 4. Okay. Then 8 by 4 which is equal to minus 2. Okay. Even if you continue this, the next one will be minus 8 by 4, that is minus 2. 4 2s are 8. So minus 2. Okay. So how to represent the number, rational numbers on the number line, that you have understood, isn't it? So let me do. Write the rational number numbers are left. You have to complete it. See, you know, you see the denominator. It divides into 5 equal parts. So if it is 0 by 5, the next number will be, yes, 1 by 5. So A is 1 by 5. 2 by 5, 3 by 5. B is 5 by 5, 4 by 5, isn't it? B is 4 by 5. 3 after 3 it is 4 by 5. What is C? C is 5 by 5, which is equal to 1. 5 by 5 is equal to 1. 6 by 5, 7 by 5, yes, 8 by 5, 9 by 5, 10 by 5, 11 by 5, 12. Isn't it? It is very easy. So what is the rational number of A is 1 by 5. B is 4 by 5. C is 5 by 5, which is equal to 1. D is 8 by 5 and E is 9 by 5. Now see the board. Okay. If you see the board, see the denominator. It is divided into 6 equal parts. Now you can say minus 12 by 6, minus 10. So minus 10, minus 12, in between which will exist? Yes, very good. Minus 11 by 6. Again, minus 10 by 6, minus 9 by 6. Yes, minus 8 by 6. Very good. Minus 7 by 6. Minus 6 by 6. Then, very good. Minus 5 by 6. Minus 4 by 6. Minus 3 by 6. Minus 2 by 6. Minus 1 by 6 and 0 by 6. Okay. So now if you see, it is greater to smaller or smaller to greater. Which one? You tell me. You must tell me. Smaller to greater? Yes. Minus 12 by 6. Minus 11 by 6. So J is minus 11 by 6. Minus 10 by 6. Minus 9 by 6. Minus 8 by 6. So I is minus 8 by 6. What is H? Minus 7 by 6. Minus 6 by 6, which is equal to? Yes, minus 1. Then minus 5 by 6. So G is minus 5 by 6. Minus 4 by 6. Minus 3 by 6. Minus 2 by 6. F is minus 2 by 6. Minus 1 by 6 and 0 by 6. Okay. Understood now how to represent the numbers on the rational numbers on the number line. Okay. Number line, when you have positive and negative, it will be always from smaller number to greater number. Smaller number to greater number means the numbers are in, yes, ascending order. can write innumerable rational numbers between any two rational numbers. So, you can give, can you tell the natural numbers between 1 and 5? So, if I ask you, can you give the natural numbers between 1 and 5? You know between 1 and 5, which are the natural numbers exist? 2, 3 and 4. So, you can say there exist 3 natural numbers between 1 and 5. They are 2, 3 and 4. How many natural numbers are there between 7 and 9? Between 7 and 9, 8 is there. Isn't it? 7, 8, 9. So, there is only one natural numbers between 7 and 9. Then, how many natural numbers are there between 10 and 11? Between 10 and 11, any natural number exists? No. There is no natural number in between 10 and 11. So, if I ask between 1 and 5, you said 3, 4, 5. 2, 3, 4. So, 3. Between 7 and 9, it is only 1. Between 10 and 11, there is none. No natural numbers. Similarly, if I ask you in integers, between -5 and 4, write the integers between -5 and 4. You will write -4, -3, -2, -1, 0, 1, 2, 3. Isn't it? These are the integers between -5 and 4. So, you can say there are how much? 8. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 integers between -5 and 4. How many integers are there between -1 and 1? If I ask. So, on the number line, you know, between and 1, there is a integer called 0. Only 1. So, how many integers are there between -9 and -10? There is no integers between -9 and -10. So, this and all you already learned in your previous classes. You know about all these things. Okay. So, if I ask you to write the rational numbers between 3 by 10 and 7 by 10. Yes, definitely you can, because both are having 10 equal parts. So, what is there between? Yes, you can write 4 by 10, 5 by 10, 6 by 10. So, there are 3 rational numbers between 3 by 10 and 7 by 10. But you can write many. That you will learn now. Okay. So, similarly, if I ask you 3 by 10 and 7 by 10, if I ask you, because I told you first itself, you can write so many rational numbers between any two rational numbers. That is indefinite. Infinitely many rational numbers can be written between any two given rational numbers. So, how it is possible? See, here only 3 I got. Miss, you told infinitely many. Yes, I can change the denominator by multiplying both numerator and the denominator by the same number. See, if I multiply by 100, both numerator 301 by 1000, 302 by 1000, 303 by 1000, 304 by 1000 up to 699 by 1000. Yes, you get more, isn't it? So that's why they will say, if you multiply, since I have got multiply by 100, if I multiply by 1000, yes, 3001 by 10,000, 3002 by 10,000, 3003 by 10,000. So 6999 by 10,000. Again you get infinity. So hope you have understood there can be, you can write infinitely many rational numbers between any two rational numbers given. Okay. Let me continue in the next class. Thank you, students.